It begins not in the earth, but on the asphalt. The world's most abundant steel mine is a place you see every day. This massive stream of steel flows directly from the automotive recycling industry, a global force turning old vehicles into new resources. In the United States alone, over 12 million vehicles are taken apart each year, transforming vast scrap yards into the most productive steel mines humanity has ever known. Here, every vehicle, seemingly at the end of its usefulness, begins an unexpected second life. It is a journey of deconstruction and rebirth, where aging cars are broken down to become the raw foundation for new construction, vital industries, and even the very automobiles of tomorrow. It begins as a $48,000 dream, but after 10 years on the road, what is left of its value when it reaches the end of its life? The answer fuels a $60 billion annual industry, where millions of vehicles are methodically dismantled, crushed, and ultimately reborn. This global process not only sustains hundreds of thousands of workers, but also dramatically cuts costs for metal smelting and eases the immense strain on our environment. If iron ore is a resource mined from the earth, then these retired automobiles represent a vast, artificial mine with seemingly endless reserves. Every single recycling cycle conserves up to 74% of the energy that would otherwise be spent extracting new raw materials from the ground. On average, a remarkable 75% of a vehicle's entire weight can be salvaged and returned to the supply chain, from its steel and aluminum frame to its glass and plastic fittings. Through this transformation, hundreds of millions of tons of material are given a new beginning each year, continuing their journey as buildings, everyday products, and the next generation of automobiles. It arrives as a relic of the road, its journey over. But in this place, its story is far from finished. When a car reaches the end of its life, it is delivered to the intake area of a recycling plant. Here, technicians document its identity, recording the vehicle identification number, engine number, year of manufacture, and overall condition, along with all related paperwork. The car is then photographed, a tracking code is attached, and the full data set is uploaded into a digital management system. This process not only allows the entire journey to be tracked, but also provides the basis for assessing the remaining value of each vehicle. An inspection focuses on components that can be reused, such as engines, transmissions, electronics, and interior parts. These usable components are separated and supplied to the multi-billion-dollar market for used auto parts. Vehicles that are heavily damaged or fully worn out, on the other hand, are directed straight into the dismantling process for material recovery. Once this stage is complete, the cars are organized in lots across the yard, lined up and ready to enter the processing line in a clear, systematic order. What few people realize is that in the United States, more than 95% of end-of-life vehicles go through this system, making automobiles the most recycled consumer product in the world. Thanks to this level of organization, every car is able to maximize its recoverable value and contribute back to the economy. Its lifeblood has been drained, its voice silenced. But for this machine, the end is merely a new beginning. With all fluids removed to ensure the safety of the line, the car is now ready for the disassembly of its major components. The process begins with the wheels, their bulk and straightforward composition, making them the logical first target. The old tires themselves represent a stubborn form of waste, capable of lingering in landfills for decades. To avoid this fate, most are shredded into fine rubber granules, destined for new life in asphalt roads or soft playground surfaces. Others are repurposed as a potent fuel source for industrial furnaces, while their steel and aluminum rims are separated and dispatched directly to smelters. From there, specialized tools slice through the seals of the windshield and windows. This is no ordinary glass. It is a laminated composite, fortified with a tough polymer layer that prevents it from shattering. The recycling process ingeniously recovers both materials, reclaiming the glass and the valuable polymer for reuse in soundproofing and industrial coatings. Next, the doors are lifted from their hinges, revealing a complex assembly of different materials hiding within a simple panel. The steel or aluminum frames are cut free, bound for the furnace, while the intricate inner workings, electric motors, locking systems, and wiring are carefully stripped to harvest their copper, plastics, and magnets. The focus then shifts inward to the vehicle's cabin, where seats, dashboards, and carpets are systematically dismantled and sorted. Wiring harnesses are pulled free to liberate their copper cores, as plastics and fabrics are shredded and prepared for repurposing into new materials. At last, the heart of the machine is extracted. The engine and transmission, the heaviest and most valuable assemblies, are carefully hoisted out. Some are destined for refurbishment and resale, while others are broken down to yield a trove of aluminum, steel, copper, and even precious metals from their catalytic converters. This meticulous sequence unlocks the final value from every part, while ensuring the bare frame is ready for the immense forces that await it. But even after this careful stripping, the frame is not yet pure metal. A stubborn mix of non-metallic remnants clings to the chassis, from bent exhaust pipes to large plastic panels and tangled wires. The vehicle is moved to a rough processing zone, where a colossal mechanical arm, armed with hydraulic shears, takes over. Wielding tens of tons of clamping force, the immense steel jaws rip away any lingering doors and yank out entire exhaust systems in seconds. Plastics, foam padding, and other materials that cannot be smelted are unceremoniously cast aside on the spot. This raw mechanical power cleans the frame far more rapidly than any manual disassembly could, acting as a critical filter for the entire line. It eliminates anything that might ignite, contaminate the recovered metal, or damage the crusher itself. After just a few moments in its grip, the vehicle is reduced to a clean shell of steel and aluminum, ready for compaction with maximum efficiency and safety. An immense force gathers, ready to erase a vehicle's form in a single deliberate act. Once stripped to its skeleton, the bare steel frame is moved into the maw of a massive hydraulic press. Here, under a crushing weight of 150 to 200 tons, a structure once over 4 meters long is squeezed into a compact block of metal, its volume shrinking to a mere tenth of its original size. Depending on the facility's needs, this compression is achieved by different machines. The car baler method forges the frame into a dense, cube-shaped steel bale, creating high-density blocks perfect for stacking, storage, and transport. Modern industrial balers can process 25 to 40 cars per hour, suiting large-scale operations that require efficient storage before the final shredding. In contrast, the car flattener is often favored in smaller or mid-sized scrapyards. It compresses vehicles into thin sheets just a few dozen centimeters thick, a process prized for its speed, lower energy consumption, and reduced investment cost. The trade-off is that flattened cars are less dense than bales, demanding more energy during the subsequent shredding stage. A third path, the shear baler, both compresses and slices the vehicle into short, manageable sections, offering a more direct route to the shredder or even straight to the smelter. Once compacted, the dense steel masses are fed into the mechanical heart of the entire line, a high-capacity shredder. Inside its chamber, colossal steel shafts armed with interlocking teeth rotate in opposite directions, grabbing the compressed block and tearing it apart in seconds. The thunderous clash of metal fills the air as a machine that once filled a parking space is reduced to a cascade of uniform fragments. The sheer throughput is staggering, with a modern industrial shredder capable of processing 100 to 150 tons of steel every hour, or hundreds of vehicles each day. This efficiency allows the industry to operate at an immense scale, turning mountains of scrap into a steady stream of raw material. From the shredder, the mixture of metals and non-metals travels along a sophisticated sorting line. Powerful magnets first lift out the carbon steel, while eddy currents deflect aluminum and copper into separate channels. The remaining plastics, rubber, and fabric residues are discarded. The recovered steel is then compressed into bundles for the furnace, while pure aluminum and copper are collected for other industries. In less than an hour, a single discarded car yields its precious metals, ready to re-enter the cycle of production. From a jumble of twisted metal, a new order is forged in fire. A journey that began in the scrapyard now faces its most violent transformation. The compacted bundles of what was once a car frame are now fed into an electric arc furnace, where they are plunged into a waiting inferno. Inside, graphite electrodes unleash currents of tens of thousands of amps, creating an arc of artificial lightning that scorches the air. Temperatures quickly climb beyond 1,600 degrees Celsius, causing the scrap steel to glow cherry red before collapsing into a flowing stream of liquid metal. To purify this molten bath, lime and flux are introduced, which bind to impurities and float to the surface as a layer of slag, while powerful oxygen lances burn away any remaining unwanted elements. From a chaotic heap of scrap, a glowing sea of pure steel emerges, its composition continuously monitored by sensors and spectrographic analysis to meet precise specifications. This refined molten metal cannot be left to cool. It is immediately guided through sealed troughs and into the continuous casting line. Here, a blazing river of liquid steel pours into water-cooled molds, where it solidifies in mere seconds to form a hardened outer shell. With its core still molten, the newly formed steel is carried forward on a bed of rollers, cooling gradually as it travels. This process gives birth to long billets that can stretch for tens of meters, forming square bars for construction or flat slabs destined to become sheets and coils. Automated thermal saws then descend, slicing the continuous lengths into standard segments, each weighing several tons. Every piece is meticulously numbered, scanned, and logged into batches, transforming a formless pool of metal into defined blocks of raw material, marking a new chapter in its life cycle. As they exit a reheating furnace, the glowing red billets surge directly into the hot rolling mill. Here, dozens of massive, synchronized rollers begin their work, continuously pressing, stretching, and bending the steel into new forms. With each powerful pass, the heavy, rough blocks flatten and lengthen, evolving into uniform sheets or tightly wound coils. High-speed cameras and laser sensors track every millisecond of the transformation, measuring thickness and straightness with microscopic precision to guarantee every strip conforms to standard. But the freshly rolled steel is not yet finished. It must first undergo a controlled cooling process. High-pressure nozzles envelop its surface in a cloud of white mist, rapidly dropping the temperature without introducing stress fractures. Afterward, powerful fans blow across the length of the coils, allowing the metal to cool down gradually and preserve its internal crystalline structure. Once it reaches a safe temperature, each coil is subjected to a rigorous inspection. Ultrasonic sensors scan deep within the metal for hidden flaws, while high-resolution cameras scrutinize every detail of the surface. Only the coils that pass every test, including measurements of tensile strength, are stamped and moved to storage. Their journey from fiery brilliance to stable strength is now complete, emerging ready to serve hundreds of modern industries. It sits silent, its road-worn journey seemingly at an end. Yet this is not a final resting place, but the beginning of a profound transformation. The cycle of renewal starts with a meticulous dismantling, as every component is stripped away and all fluids are safely drained. Massive presses then apply hundreds of tons of force, compacting the empty shell before it meets the thunderous roar of the shredder. From the resulting chaos of fragments, a precise sorting process begins. Powerful magnets lift ferrous metals, while eddy currents repel non-ferrous materials, and advanced sensors identify and separate the remaining elements with surgical accuracy. The purified metal is then fed into the furnace, where intense heat melts it down, erasing its former identity to forge new steel. This reborn material is hot rolled into shape, carefully cooled, and rigorously inspected. What emerges is a clean, durable foundation for vital industries destined to become the framework for construction, the heart of new machinery, or even the body of another automobile. Each vehicle, instead of being discarded, becomes fuel for a multi-billion-dollar industry, dramatically cutting energy use and relieving the strain on our planet's natural resources. It is a hidden pillar of the modern economy, proving that an end is often just a new beginning in disguise.